Bismillahirrahmanirrahim. Assalamu alaikum. I am Muhammad Hassan Ashraf, the course instructor for this applied ecology. Today our topic of discussion is treatment of wastewater. Wastewater treatment includes three basic steps, in which the first two are more important, and usually these two are commonly used, and rarely the third one practice is also applied for the treatment of the wastewater. The first method is called as the primary treatment, the second one is the secondary treatment, and the third one is the tertiary treatment. Primary treatment removes material that will either float or readily settle out by gravity. It includes the physical processes of screening, combustion, grit removal, and sedimentation. These are the four sub steps of the primary treatment for the removal of different physical agents which are easily removed, which are floating on the surface of water, or they can be easily settled down. First one is the screening. Screens are made of long, closely spaced, narrow metal bars. They block floating debris such as wood, rags, and other bulky objects that could clog pipes or pumps. So for this, those particles or those agents which are in larger size and can block the passageway of the pipes are firstly separated by screening. In modern plants, the screens are cleaned mechanically and the material is promptly disposed of by burial on the plant grounds. The second one, physical category of the primary treatment, is combustion. A comminutor may be used to grind and shred debris that passes through the screen. The shredded material is removed later by sedimentation or flotation processes. Next is the grit chambers. Long narrow tanks that are designed to slow down the flow so that solids such as sand, coffee grounds, and eggshells will settle out of the water. Grit causes excessive wear and tear on pumps and other plant equipment. Its removal is particularly important in cities with combined sewer systems, which carry a good deal of silt, sand, and gravel that wash off streets or land during a storm. Sedimentation process. Suspended solids that pass through screens and grit chambers are removed from the sewage in sedimentation tanks. These tanks, also called primary clarifiers, provide about 2 hours of detention time for gravity settling to take place. In the sedimentation tanks, the water is stopped for about 2 hours. During this time, the suspended solid particles they settle down at the bottom of the sedimentation tank. Sludge. As the sewage flow through them slowly, the solid gradually sink to the bottom. Means as the water flow from the sedimentation tank slowly, the solid material is going to be settled down. The settled solid, known as raw or primary sludge, they are removed along the tank bottom by mechanical scrapers. Sludge is collected in a hopper where it is pumped out for removal. Mechanical surface skimming devices remove grease and other floating materials. Here is the diagram which showing the different steps of primary treatment as well as for the secondary treatment. So during the initial stages, when the severe water or the water from different sources comes into the treatment plants, So the primary treatment starts with the screens. Raw sewage when enter, these screens in the form of the bars, they filter the large particles and don't allow them to enter into the pipe streams. These screens separate the solid materials, and the water with the suspended material can go forward. Then there is a cumulator. That cumulator further grinds the larger particles which pass through the screens, and then that is allowed into the grit chamber. Grit chamber, there is again water is suspended particles, some they settle down and they are allowed to remove from the water. Then the water is moving toward the primary clarifier, which is also the sedimentation tank. Here the water is suspended, or water is kept for about 2 hours. In that time, most of the suspended solid particles, they become settled down and in the form of sludge, and that sludge can be removed through this pipeline for its treatment. And from this primary clarifier, it is now called as the primary effluent. It enters toward the secondary treatment. During the secondary treatment, there is the first step, which is the aeration tank. Here is the air compressor, which compresses air and allow that air to enter into the water to which was come after the primary treatment. And then that water is allowed to move further for secondary clarifier. Then here is again the sludge formation takes place. That sludge either can be removed, and the water is again pumped, or some sludge is again pumped back, so that sludge contains some microbes which perform the decomposition in this tank over here, or in the secondary clarifier. Then the secondary effluent is disinfected by addition of some disinfectants like the chlorine, and then it allowed to be discharged to surface water or tertiary treatment if needed. So in this diagram, the both methods are discussed for the processing of the wastewater, the primary treatment and the secondary treatment. Secondary treatment removes the soluble organic matter that escapes primary treatment. It also removes more of the suspended solids. Removal is usually accomplished by biological processes in which microbes consume the organic impurities as food, converting them into carbon dioxide, water, and energy for their own growth and reproduction. There are three basic biological treatment methods. One is the trickling filter, second is activated sludge process, and the last one is the oxidation pond. In the first one, the trickling filter. A trickling filter is simply a tank filled with a deep bed of stones. Settled sewage is sprayed continuously over the top of the stones and trickles to the bottom, where it is collected for further treatment. As the wastewater trickles down, bacteria gather and multiply on the stones. The steady flow of sewage over these growths allow the microbes to absorb the dissolved organics, thus lowering the biological or biochemical oxygen demand of the sewage. Air circulating upward through the spaces among the stones provides sufficient oxygen for the metabolic processes. Settling tanks. These are also called as the secondary clarifiers, follow the trickling filters. These clarifiers remove microbes that are washed off the rocks by the flow of wastewater. Two or more trickling filters may be connected in series, and sewage can be recirculated in order to increase treatment efficiencies. As we discussed in the diagram shown previously, that settling tanks, from the settling tank, the water is again recirculated into the trickling filters for the removal of the organic wastes. Second one is the method of the secondary treatment is the activated sludge. The activated sludge treatment system consists of an aeration tank followed by a secondary clarifier. Settled sewage mixed with fresh sludge that is recirculated from the secondary clarifier is introduced into the aeration tank. Compressed air is then injected into the mixture through porous diffusers located at the bottom of the tank. As it bubbles to the surface, the diffused air provides oxygen and a rapid mixing action. Air can also be added by the churning action of mechanical propeller like mixers located at the tank surface. So in this mechanism, particularly there is addition of the oxygen for completing or for fulfilling the requirements of the BOD, and also this oxygen help in the mixing of the waste and the oxygen and allow the different microbes to perform their activity. In the activated sludge, further, under such oxidation conditions, microorganisms thrive, forming an active, healthy suspension of biological solids, mostly bacteria, which is called activated sludge. About 6 hours of detention is provided in the aeration tank. This gives the microbes enough time to absorb dissolved organics from the sewage and reducing the BOD. The mixture then flows from the aeration tank into the secondary clarifier where activated sludge settles out by gravity. Clear water is skimmed from the surface of the clarifier, disinfected and discharged as secondary effluent. The sludge is pumped out from a hopper at the bottom of the tank. About 30% of the sludge is recirculated back into the aeration tank, where it is mixed with the primary effluent. This recirculation is a key feature of the activated sludge process. The recycled microbes are well acclimated to the sewage environment and readily metabolize the organic materials in the primary effluent. The remaining 70% of the secondary sludge must be treated and disposed of in an acceptable manner. So the activated sludge, the 70% of that sludge is further sent for the treatment, and the 30% is sent in the primary effluent and mixed in the primary effluent for the breakdown of the organic compounds present in that water. Third mechanism of the secondary treatment is the oxidation pond. Oxidation ponds, also called lagoons or stabilization ponds, are large, shallow ponds designed to treat wastewater through the interaction of sunlight, bacteria, and algae. Algae grow using energy from the sun and carbon dioxide and inorganic compounds released by bacteria in water. During the process of photosynthesis, the algae release oxygen needed by aerobic bacteria. Mechanical aerators are sometimes installed to supply yet more oxygen, thereby reducing the required size of the pond. Sludge deposits in the pond must eventually be removed by dredging. Algae remaining in the pond effluents can be removed by filtration or by a combination of chemical treatment and settling. Tertiary treatment. When the intended receiving water is very vulnerable to the effluents or to the effects of pollution, secondary effluent may be treated further by several tertiary processes. So sometimes this mechanism is not required. Sometimes after secondary treatment, the water is directly drained into the water bodies. But if the source or sometimes it happened that the water after secondary treatment have many different type of nutrients, particularly the phosphorus and nitrogen in it, that should be removed for converting that water being usable. So tertiary treatment is required of such water. Effluent polishing. For the removal of additional suspended solids and biological oxygen demand from secondary effluents, effluent polishing is an effective treatment. It is most often accomplished using granular media filters, much like the filter used to purify drinking water. Polishing filters usually build as prefabricated units with tanks placed directly above the filters for storing backwash water. Effluent polishing of wastewater may also be achieved using micro strainers of the type used in treating municipal water supplies. Here are the picture which is showing the tertiary treatment. In the tertiary treatment of wastewater, in the left here the mechanism is shown, which is the filtering, and on the right the mechanism is shown, which is the backwashing. So during the filtering step, wastewater from secondary treatment still containing suspended solid pour from a trough and percolate through a filter bed made of porous media such as sand, gravel, and anthracite. The filtered water is then piped away for disposal. So here is the mechanism. From this pipe, the water from the secondary treatment is entered over here. Here is a trough. Through that trough, water moves and percolates through this filter tank. From this filter tank, then it is moved further in the form of treated water. From here, this water is further sent for its disposal. And here is a control panel which control the amount of water which have to be removed. Sometimes the water without sending forward, some of the material, some of the wastewater is sent back. That will be, here is the backwashing. At the right, in the backwashing step, entrained solids are periodically flushed from the filter media by pumping filtered water back through the assembly. The backwash water carrying suspended solid is returned to the beginning of the wastewater treatment process. Here, the water is sent back in the backwashing process, where that water is sent back for the primary treatment. So during this mechanism, instead of being sent for the further after filtering water, some water is sent back, which is the backwashing, for the primary treatment, which should be started again, and then the secondary treatment followed by the tertiary treatment. Removal of plant nutrients. When treatment standards require the removal of plant nutrients from the sewage, it is often done as a tertiary step. For example, phosphorus. It is usually present in the form of organic compounds and phosphates that can readily be removed by chemical precipitation. This process, however, increases the volume and weight of sludge. Nitrogen. It is present in sewage in the form of ammonia and nitrates. Ammonia is toxic to fish and is also exerts an oxygen demand in receiving waters as it is converted to nitrates. Nitrates, like phosphates, promote the growth of algae and the eutrophication of lakes. A method called nitrification and denitrification can be used to remove the nitrates. These are the references for the treatment of wastewater. Thank you. Allah Hafiz.